in our daily life, but you need to know how it is made from scratch until end. So in this session, I'll be sharing with you my knowledge and how are we building a mission from the start until the end. So without further ado, I think let us jump into our session. Okay, so these are the content we'll be going through the session. First is what is automation, history of automation, basics and principles, robotics and automation, basics and principles, types of robots, and the mechatronics relation with this industry, and then we'll go to the conclusion and summary. So before I start, I would like to also tell you that you no need to read all the slides. The slides what I've given and the definition I've given is just when I'm giving this slides to to all your students. It's just when you need to just get when you're reading the slide by yourself. When I'm here, I think I would explain from start until end, so you don't need to keep on reading. Sometimes I've also experienced that some speakers will be speaking and you need to keep on reading while they're speaking. So I think for my session, it'll be like mostly I'll be explaining every single thing, so you don't need to keep on reading. You can focus on what I'm explaining to you. So sorry for that, for the noise. Okay. Okay, so automation. So normally the automation is something like which makes our work more easy and reduces human machine. Normally we ought to do a lot of work in the previous ages and previous generation. Right now you've seen a lot of automatic things which have come inside our life, and I would say it has more than occupied a lot in our life actually. So I would say that, sorry.
So sorry for interrupt your session,
Yeah.
sir, but the slides are not moving, sir.
Okay, slides are not moving. I think there is a glitch because I can see it's moving. Maybe I would move a bit slower. Can you see my screen currently?
So only we can see first slide, sir.
Oh, okay.
Very first slide, yeah.
Okay, then I think I will better go in this view so that you can see.
Yeah, now we can see automation.
It's better I go in this way instead of full screen. It will be lesser glitch when
okay,
going
okay,
through.
Sir. Okay.
Okay.
Okay, sir. Fine.
Thank you,
Okay.
sir.
So okay, all right. So automation, like something which is now inside our life a lot, and not just big or great machines is automation. Every day we see a lot of automation in our day-to-day life. And I think you've all known the first ever automated machine or automated equipment we've made. It will be interesting because the first ever automated invention was a clock. Because previously, you remember, you will be going through, in medieval times, we will be going through shadows to determine the time. The first ever equipment which was made was actually a clock. And then it was followed by different inventions, which is the windmills, steam engines, etc. And currently, like current generation, I would say it's very much advanced and it is used to test sensors, microchips, and also the assembly of servers and etc. So in that line, our company is making something like every solution, every automated solutions which a consignee or customer requires us to do. So in this session, we'll be going through detail, step by step. Any doubt, you can note down and you can ask me at the end of the session. I'll be free to answer to any of your questions. And one more thing I would also like to emphasize is that our company is specialized in automation and robotics is just a tool we are using. So, and some more, my job view and job scope is something like I need to manage the engineers. So more of technical data, I might be lacking somewhere in technical data, but I think I will give my best on whatever I know I will chat to you. So if let's say there is something else you ask and which I don't have the answer currently, I will surely get advice from my engineer and get back to you. And I think, so let's go to the next slide. So for automation, basics and principles, I've listed down all the from the start and then what is the process we'll be doing to build a machine. So this is the second half of the process, and the first half is something like you will receive it's something like a documentation and everything. I think that is not much will interest you. Just to give a small introduction is that normally when customer is or consignee needs a automation equipment or some solution to test their product or assemble their product, they will give us a document called as ERS, which is engineering requirement specification. So from that, you will know what kind of solution customer is interested in or what kind of solution we need to build in. And I think this is something like the first ever step in a machine equipment or manufacturing system. So once you get the requirement from them, then you go through with your team and then you will propose a solution and a whole package as this can solve your issue or this can address your solution. So currently I will go through step by step together with you, and I think it will be easy for you to understand as well. So the first thing, first ever step after you receive the ERS is something like mechanical and electrical design. So for a scratch of a machine, you need to know why or how are we going to propose a solution to a customer or consignee. So when customer is giving us an requirement, we need to design our equipment based on their requirement or application which we need to introduce. So something like mechanical and electrical design is you need to, like if you're giving a solution to customer, you need to give a whole package. So something you need to start with structure, the circuit and the standard fabrication parts, everything. So normally this design will take around like, let's say if there is a very big machine, it will take around eight weeks or something. But if let's say it's an average timing, it will take around 4 weeks for the mechanical and electrical design. So once they finish their mechanical design, they will move to the parts purchase. So this parts purchase is actually in our machine or in our solution, we need to use various amounts of parts. There's hundreds and thousands of parts we need to use. So something is like standard parts and fabrication parts. So standard parts to say is standard parts is something like long lead items and which is already available in the market. So this kind of parts is something like the robots and the automation equipments used in the machine will be standard parts. And the fabrication parts is something like we need to release a drawing and then a vendor or your vendor would do it for you. Means you will release a drawing and will do the parts for you. This one you can receive in very less time. Or the standard parts which is already in the market will take more time to reach you. So this kind of standard parts is, as I said, it is something like a long lead item. And once you finish your design, you will send your package to customer, and the consignee will make sure that everything is satisfied, every condition is satisfied, and then they will give us you can proceed or approval to proceed the parts purchase. So next step, okay, so I think you're following up with me. So the first step is the mechanical design and the electrical design for the circuit, and then you will go into parts purchase. And after the parts purchase, we will start the assembly and wiring. So once you receive all the parts, you will start to assemble the structures and also the parts of the machine which is required to be done. And this will take around 3 weeks or 4 weeks of time to assemble the machine and do the wiring and equipment. Because each and every part will be communicated through I/O systems. So this I/O is something like input and output. I give you a signal and then you acknowledge back. So this is the principle we use in automation machines to communicate between different parts. So with the I/O is something like the nervous system of your body. You need to give them a signal, then they will react back for your signal, something like that. So this is the next part, which is assembly and wiring. So after you finish the assembly and wiring, you will have a structure already, and you will already have all the parts installed and the wiring is done. Then the next step, you will go to the I/O testing. This is what I said, that's input and output. So normally what we do, we have a system called as PLC. So the communication is something like all the mechanical and electrical parts will communicate to PLC and then modify or execute the command that you are giving. So this I/O will be controlled by a PLC system, which is I think in Mechatronics you also have a paper on PLC programming, if I'm not wrong. So this PLC programming is something like is a code and then you will go through each and every step. You will write the code on how the machine should move and what should it do exactly. So after writing the code, then you will test the communication between the parts and the IO, whether you are receiving everything you need or not. And then after doing this IO testing, then you will move to the dry run. So once you get all the communication of the machines, you will get the values or whatever the steps you are required. Once you get to see all those, then to make sure that your PLC is working correctly, you will run through dry run. Means you will just let the machine run. So this dry run is something like to make sure that your hydraulics and pneumatics of the machine are working properly. And one of the basic things of this machine is that this machine is, whatever machine we are building is completely based on to satisfy customers' requirement of their product. Sometimes customer might need us to assemble a product in a conveyor, or they might require to test their product to make sure it is okay. For example, if you are having your phone, there are a lot of microchips and everything inside that, but you don't know whether that chip is faulty or it is working correctly. So that is where we come into action and make sure that this part is exactly working as per required. So we will do a set of tests for that microchips and make sure that it is working correctly, and then only it will release to production. So this is something like each and every customer product is we need to test or assemble and then give the end product to customer. This is why we are building automation things. Actually, you can ask me why can't I, if let's say this is just assembling a product to another product, I can just do it in hand. Why do I need to do automation? So the answer to your question will be, you can do all the assembly you want, but if let's say customer require the product of 1 into 1 mm size, and you need to attach into like 2 mm into 2 mm size, you cannot make sure that it is accurately placed or it is accurately connected to the part of the system. So that is where we use high accuracy robots and all the automation systems to make sure the accuracy is correct, and then we install the parts to the product. So after the coming back to the topic, after the dry run, what we will go is point teaching. So if let's say we are using a robot, and also one thing which I would like to share also is currently the robot what we are using we need to make sure we are all engineers, and we need to make sure that robot is not only humanoids. There are various amounts of lakhs and lakhs of amounts of robots which actually does the work for it, but it is not actually a humanoid. This robot is something like it's just maybe like a hand or something, so it will have an end of line tool. So this is where we used to pick the customer's product and then test or place it somewhere or assemble somewhere. So this is the kind of robots we use in automation industries. So once the robot is placed to our system, what we will do exactly is we will make sure that we will have a tray or a position where the customer's product will be in place, and we will make sure that the robot picks it properly and then places it properly. So we need to teach the point for the robot, saying that this is where you pick and this is where you place. Until and unless you teach the robot cannot do anything. So you need to feed it like a baby, that you need to do this, you need to do that, you should not go hit here and everything. Obviously, the robot will have safety sensors, but sometimes during production run, like 24 hours or 48 hours together, the robot might be too stressed up, and something, when it loses its connection, it will go bang the door or something like that. So that is why we actually teach the robot on the exact position to pick and exact position to place. This is how we actually pick and place the product of the customer. And to make sure that our robot is not damaging the customer's product before going to production, we will have some vision systems. So vision setup is something like a camera to make sure that your product is picked and placed properly. So in the automation industry and in the world, around 93.7% of automation or equipment is actually based on the vision system's signal. If the vision system says this product is failed, it is failed. Or if it is say that you are placing like 0.1 mm tolerance or offset to the exact point, then your product might fail. So that is where this vision system comes into product. And this vision system is something like a camera which keeps on scanning, and it is given as an algorithm by itself to make sure that our product is inside the line or inside the assembly we need to put. So this vision setup is not like a normal camera we're using, like a DSLR or something like we used to take pictures or used to do for DP and everything. This is something like a vision setup. It's like a normal small camera, but it is more expensive than our actual cameras because this can be fed up with algorithms to make sure the product is pass or fail. It can decide by itself with the algorithms we feed it that the product position is pass or fail. So this is where the vision system comes into the place. Every single step that I'm explaining to you, if you think that I'm going fast, you just note down to the point, and then at the end you ask me to explain some more in detail, I can do it for you. If you feel that something is very fast, I'm not covering somewhere, you can ask me to explain in detail at the end of the session. Okay. And proceeding to the next step, which is the testing criteria. So this testing criteria is something only applicable when customer requires us to test our product. If let's say it is only assembly, or it is only what we need to do is we need to only assemble, we don't need to do all this testing criteria. But if let's say our product is something we need to test before giving to the production, means it's like a sensor or light sensor or something. Normally we use in our iPhone or in all the phones currently, you can see auto brightening the screen and then coming back to the normal. So these are all microchips used and micro sensors used on the face of your phone, so that it can detect the light which is outside in the environment and then reduce or increase the light as it is required. So these are all, if let's say we don't test this product, the product will not do its job. Sometimes if let's say the product is not tested properly, you put that inside your phone. If you need light, that time it will go down the brightness, and if you don't need light, you need to dim up, then it will go very high brightness. Something like this might happen if let's say your product is not tested properly. So what I say completely reveal the consignee or the product we are testing, but I can give you a clue is that the sensor we are testing and the products we are assembling is world's very large legendary companies, which are the fruit company and the search engine company. I think you should have guessed by now. So these companies require very strict protocols to follow, and we need to pass their criteria, or else we will fail the buy off, and then we will need to buy all the loss that the company faces. So in order to design a machine, from the required document until the end, we need to go through each and every line so that we don't miss any of the criteria we need to test. So coming back to the testing criteria, as I said, if it is only assembly or other type of automation required, we don't need to test the product. But if let's say it's something like a sensor or something, then you need to do the testing for the product. And then comes the full sequence test. After you do the testing of the product, then we will let the machine run in the full sequence, means from the start of picking the product and inside it is placing inside your machine, and your machine is doing the testing. And after that, you pick the product and then place in the tray. So in between of this, at the start of the system, your vision system will capture the image of the product, and after the end of the session, it will also capture, because customer will also, they are very strict, so that they will also know that if my product is like this in the beginning, once it goes into your system and then comes out, it should be in the same cosmetic. It should not have any damages or something. That is why we use the vision systems to capture the product, what we are doing. And after testing, we will again capture it so that we can show as a proof that your product came in and came out as it is from the start until end, and there is no damage initiated. So after this full sequence test, normally we go into the GRR. GRR is something like golden repeatability and reproducibility. So somewhere like the products used in the customer sensors, right? So you will have like, if let's say I test only one module at a time, for 1 hour, I'm only testing one module. So the production and the systems will have very less production, and like you can only produce 30 sensors per month. That is not the actual case in our automation world today. This, in current technology and in this generation of automation, you are testing like hundreds of parts in minutes. So it's like your testing time is like 9 seconds for each unit, so that you can pass down and move to the next unit simultaneously. So when testing all this, all the places where you hold the module, the customer will like to make sure that each and every position in your module is giving the exact same data which is collected by the products. Because what I'm saying is data is something like every socket, once you engage and communicate with the module, I mean to the product, your product will give you the results. Means you will give volt or current to the product, and then it will power on, and then you need to test some criteria, and then the data all will be logged inside a CSV file. It's like something like an Excel file where it will log on all the data. So after that, this data will be provided to our consignee, and they will go through the data. They see everything, the data is perfect. Then only they will release the machine to run production of testing the actual product. So when GRR is something like we will test the same product in all the holders, we need to hold the module to make sure that this product is getting, it won't get exactly the same value, but there will be changes in microns or the value of after the decimal points, but it is still comparable between all the products. So what we do is we actually load the module to the holder, and then the same module will go through all the holders to make sure that this machine is producing all the hardware in the machine is same, and it does not create any variation in the test results. That is why we will do the GRR to make sure our machine is fit for going through the production run. So I think more or less I've covered something of full of automation. I think I'm going a bit fast, but later when you ask in the interaction, I could be some more slow and explain to you in some more detail. So I think this is how automation machine from the design until the end of the criteria is done. Sorry, I think I missed out the UPH. UPH is something, as I told just now, units per hour. For every hour, there is a target from the customer that we need to meet this target. We need to, if let's say customer requires us to test 750 units within 1 hour, we need to make sure our machine can perform and test 750 units within 1 hour. That is what called as UPH, which is unit per hour. So once this is the last step of the buy-off. So once the testing criteria is met and the UPH is met, then our machine will be buy-off, and they will start the actual production to be run and fixed in the actual applications. So this is a part of overall overview of an automation machine, how it is from scratch until the end. And now we will go into something like the robots. So robots is like heart to your machine. Without this robot or the handler, you cannot pick the module or you cannot take inside the customer's product. This is where the robotics comes inside the play, where you will go to the robotics and automation. I think this is all a general definition which I've given here, but to be simple is that robots are something which can handle your product inside your given tolerance and accuracy, and it can perform without damaging your product. This is where most of the robotics is used in automation currently. This robot, what we have placed here is something like we will do this use this robot to assemble the server of so-called search engine company. And so you will just need to, what we will do is we will have different motherboards and the RAM which we need to assemble to the server actually. So what we will do, the one in the one hand on the left hand side will hold the product, and the one on the right hand side will pick up and then place on the server. So this is something like the right side of the robot will have a vision system embedded to the robot. So before placing, it will capture and make sure we are placing at the right accuracy and the right time. So this is something like where we use the robotics to do our automation side. So I think going through the basics and principles of the robotics, I think first we will go through is the design and calculation of payload. Okay, all right. So first we will go into the design and calculation of payload. Payload is something like, if let's say you're going to lift up a product, you should make sure that your robot can pick up and then place without any problem. If let's say the robot is overweight and you're going to just pick up a pin, you're wasting your efforts and you're wasting your resources. So you should determine the right payload for your robot which can pick, and then it should place in the right place accordingly. So this design and calculation of payload is, normally we will have, the robot is a standard part, but our customer's product will not be a standard part. That is when they will be introducing to the market. So we need to design an end of arming tool to hold the product using the standard robot. So that is where this EO80 and where we come into the place, the calculation of payload. Every robot needs to be calculated with the payload. Without calculation of payload, you use the robot, you're wasting your resources and all your budget on the robot actually. So normally your robot now, I think the best is 7 to 8 axis you can move, the robot can move. So normally in automation basis, the most used robot is something like 6 axis. You can move to X, Y, and Z axis. Z is something like the height. And X and Y, normally X and Y of the graph, like X is the horizontal and Y is the vertical. And then the Z axis is something like the height difference between the product and the place you want to move. So these are the which is X, Y, Z. And there's also sometimes you might need to rotate the end of the tool, sorry, and then you might need to pitch between the movement. Means, let's say your robot need to pick two products at the same time, you will have two pitchings in between the holder. So that is why you will see the pitch, and yaw is something like you will move in the angle, rotation angle. So basically, previously when we do this design and the payload, or we calculate the payload and axis, we have a lot of risks to be assessed, and we need to do very complicated and messy work. But currently there is already a software which can calculate the payload for you. You just need to key in your required details, and then the system will or software will give you the required payload, so you can select the payload regarding your application. So after design and calculation of payload, you'll be going again the same process which we do in the automation. It's something I've elaborated here on separately for the robot. So first, after designing and determining your payload, you will purchase a robot. And then for installation of the robot, you cannot just place the robot inside our machine, because your robot's weight will be very high and your machine need to withstand that kind of height. So what we do is, we will, if it is a ground mount, you will place a mount on the ground, so that after above that we will place a robot. Sometimes, mostly if we need more accuracy and more speed, what we will do is we will purchase a ceiling mount robot. So ceiling mount is something you can fix to the top of the machine and it'll move from the top. So this kind of ceiling mount, you will need to require a ceiling mount to hold the robot on the ceiling. And then the pointage is what I've said previously. After you fixing the robot, you need to continue with the pointage. You need to pick up and you need to place and you need to do your accuracy measurement and everything. So after that, after your pointage is done, then that is when you will start your application. You will check all the points, the placements, and the full sequence test. All can be verified by dry running the machine. So when I come to speak as robots, robots have very different kinds of robots. That they are like majorly classified into 4 types of robots on used in our application in the current industry, which I will go into the articulated robots. I think no need to worry. I think there's only few slides left, and after that I can come to you for detailed explanation or something if you require. So the first type of the robot is articulated robots. Articulated robots is the maximum amount of robots used in the automation industry. This is something like the 6-axis robot. It can be used for various applications which I've listed down there, as pick and place, machine tending, the assembly, welding, packaging. Most of the applications in the automation industry can be done using the articulated robots. So this articulated robots is something like you will mostly it is on ceiling mount, but the ground mount wise product is too heavy. Your ceiling mount cannot hold that much amount of weight. So that is where your ground mount robot will come into use. So this is first type of the robot where you use with only one head, and then you move and in the 4 axis. And now I think it's already 7 axis you can use in the market. But I think until my knowledge, what we've used in the machine, the maximum we've used is 6 axis only. And next you can use is the SCADA robots. SCADA robots is something like a part of the articulated robot. It is something like selective compliance articulated robot arm. It's something like a short version of the articulated robot. But this, why we use this, is something more speed and has more accuracy, because we use this to take very small parts, and this has very low payload, and its movement will be like say the RPM will be very high when moving the SCADA robots. So the SCARA robots is something where we use in our current generation to pick like minute parts all to do in the testing. We'll use the SCARA robots. And I think next is the Delta robots. The Delta robots are something like you will not use only one hand, one end to pick up. You will be using like 3 or 4 hands to pick up so that your product is placed exactly in the right position. If let's say you pick only with one hand, sometimes if the module is or the product is bigger, you will not be able to place the product in the required accuracy. So that is where all the Delta robots come into place. So going to the next one is the Cartesian robots. Cartesian robots are something like it is not actually considered as robot. It is actually a semi-robot, something like. So what you do is you will build a pathway for the robot. So all it needs to move is you need to move X or Y or whatever direction you want to move. You just need to put this. But this Cartesian robots is used very less because it can be only used for very less application and very specific applications. You cannot use this for universal applications such as SCARA or the articulated robots. So these Cartesian robots are something you will not see in our day-to-day life. And then these are the 4 types of robots what we actually use in the automation industry. And then coming to mechatronics relation with industry. Okay, so coming here, actually I studied material science and engineering in BE, but the specialization, what I done, and the final year project, all was done in nanotechnology. But actually, when I came here, in our company or in our system, there are a lot of mechatronics engineers involved in each and every scope. Project managers, I think a bit less because they are more of technical related persons where their expertise will be used. So mechatronics engineer, they are like everywhere in our company, even in designing department, then the mechanical department, electrical. The maximum amount of mechatronics engineer our company hires is the PLC programmers and the HMI programmers. I think PLC programmers is a bit very straightforward and it's something like logics and circuits only. So if let's say if you learn PLC programming, it is really going to help you a lot in your future because our future, as I think in the previous, all the speakers would have stressed that currently automation is actually coming as a big part of our daily life. Every single thing now we use is more like you're seeing every day is 90% is automation. Your fan, your light, everything is automation. And I think that I would also like to give you an interesting fact is that I think most of you love bikes. As myself also, I love bikes, but there is certain companies which actually uses automation in the application. For example, the bikes you see, I think KTM. I think you should know KTM. All those KTM, you should know most of the other bikes don't have this feature. You will have a radiator and a fan and also a coolant oil, but this oil will not be the coolant will not be going into your engine or whenever your engine is getting heated. Means it has a required timing when it should go and when it should not go. So that is where the automation is actually used in the bikes also. So if let's say there is it's very simple kind of automation they use in the bikes, which is that they will have a temperature sensor in the bike, so near the engine. So when your engine is moving to a bar of overheat, then your temperature sensor will trigger the fan through I/O communication, and then your fan will start radiating, and then your coolant will go through and cool your engine. And after your engine is cooled down, it will off. The temperature sensor will again reflect back, and hey, I finished my work already, so you can stop. So this signal is given by the I/O, and then it is stopped. So this is what I'm saying is automation is involved everywhere, and you can't avoid automation in this world. You don't think that I'm speaking automation all those things. Actually, even I didn't before 2 or 3 years when I started working. So when I started working here, you will start to understand how does the automation plays really important role in our day-to-day life. So all these different kind of automation departments are actually based on the mechatronics engineers. Actually, that is why I was more interested to share my knowledge with you guys, so that you have a knowledge on how a machine is built, and then once you know this, any type of interview you can go, you can be confident that you know how a machine works and how to answer your questions which is asked in your interview. So in interview, I think the basic questions which they ask is what is I/O, or how does the communication happen between the parts, or something like this. This kind of small things, when you know, you will be more confident when you're presenting yourself in an interview. And also, it is something like a personal knowledge you keep on gaining. You cannot say at a certain point that you've learned everything. Even I, or whoever, whatever legendary people they are, they keep on learning each and every day. So you need to keep your learning attitude very like something like you should not leave your learning attitude. You should keep on learning, and you should never think that you know most of the things. When you start to think that you know most of the things, then you will actually stop learning at that point. So I think each and every day you should make sure that you learn something, even it is related to your subject or not. You learn something, then your habit will grow, and then you can learn really. You will be curious on a lot of things what is happening actually. So I think after telling you the different disciples of mechatronics used in our company, then I think I will go to the summary. And I think the summary we are going through is something like first thing is currently automation is really growing in the research and development area. And then when you are designing or defining a robot, your payload and the axis of a robot is very critical. Without knowing your payload or axis, you cannot purchase a robot. So then the main point is that all humanoids are not robots. Means only humanoids are not robots. There's a lot of other types of robots which really do a better job than the humanoids, because humanoids are actually given as an algorithm of wrong with decision making. There is a chance that they can make. But when your robot, you have teach point and fed to your algorithms, your robot will not make much of a problem. So then I think robotics is really a part of the automation industry. And then currently, as I said, mechatronics department and engineers are actually the backbones of automation industry, because you know exactly how an automation is working and how the robots are applying to this automation field. So just to revise back, just a quick wind up. Normally, I will go from automation. Normally, what you do is you get the specifications or anything from customer, then you design your machine or your application, then you purchase the parts, the standard and the fabrication parts, long lead and the short lead parts. Then after that, you actually do your assembly and wiring. After doing your assembly and wiring, you should check your communications of different parts of the machine by using I/O. And after that, you can start your dry run or full run. And by doing that, you can make sure that your hydraulics and pneumatics are working very good. And after you reach the point, after you buy off the pneumatics and hydraulics, then you will go into testing criteria, if let's say there is any testing required. And after that, after you finish your testing, you will do something like the dry run, and you will test the UPH, GRR, etc. So after you finish all these steps, you will apply for the buy off to customer, and then customer will come to your site to buy off your machine and then ship to their company, and then they will start another buy off on SAT. So there are two types of buy off. First is factory automation test, and then the other one is factory acceptance test, and the other one is site acceptance test. So once your machine is finished, you need to buy off one time in your factory, and then you will move to customers position. Let's say they're in a different place, then you will ship the machine there, and then you will go like 4 or 5 engineers there to set up the machine off again with the site acceptance test with the product. After that, they will run the production. So this is also going through your robot purchase and everything, your installation and point teach as well. And I think I've covered most of the thing. I actually intentionally made my slide very short and crisp, because I don't like to drag out of the box, and then because to fill up the time. I just need my point to be crisp and sharp to the point, so that you don't waste your concentration else, and then you just get the point what I'm coming to tell. I will share this type of slides with our Thiruvengadam sir also. So I will also attach my contact there. So if you have any doubts after this question and answer session, if you really have something to clarify with me, you can anytime you can reach me. and I think I will try to give you the best knowledge to my I'll give you the best knowledge to my best. So I think I can try to explain to my best of my ability so that you can understand. If really after that you don't understand, I will make sure that I will give you a link or something where you can learn more through more easier or application wise of way. So I think if let's say you can any doubt or clarifications after this question and answer session, you can always reach out to me. And as what I said, I'm not completely inside technical region because my job is actually to manage the engineers and give them the right direction to go so that we meet the schedule and we are inside the budget. So at the start of the engineering requirement specification, you need to get inside technical point of view so that you need to make your engineers understand. After they understand, you give them the direction and then they start working on that. After that, I need to manage the engineers so that they don't go out of the way and then put them back inside the schedule and then reach the schedule and make the machine without any problem or buy off. So this kind of actually what I would say is in automation industry, I don't know what other industry, but in automation industry, it doesn't mean that you study where or you study how much GPA you get or something like that. I'm sorry, staff, so that I'm saying this, but actually your GPA or your CGPA is just a criteria to let you inside the interview. After you get inside the interview, your GPA or your CGPA does not speak a word. Even your 10th or 12th mark, we've been growing out with lies saying that your mark is going to come with you throughout the life. No, I won't agree with that because your mark is just a criteria so that you can get an application. For that, yes, it is used. But after that, it's only your knowledge which is going to help you, or only your practical skills which is going to help you get a job, or you innovate or improve or whatever you do. Even entrepreneurs currently is something like what you have stuff in your mind is what is going to speak. It's not to say is currently even when I was studying, I'm not so called very high scoring student. I was also an average. It's just that when you study, you need to study by understanding, not mug up and then go vomit. So I think what I did, I just studied so that I did not cover all the units. It's like 5 units, the whole thing, but I did not cover. I just learn and try to understand what I'm doing and why am I doing. The first thing what an engineer should know is something like you need to reason, you need to ask why. You should never feel shy to ask why or ask questions, because when you're asking questions, you're just fool for just a minute. But when you're not asking questions, you are fool for a long time until you know the answer. So anytime or anything, even it's a silly question, don't feel shy to ask. You just need to shoot up the question and you should get the answer. So this is how you need to develop as an engineering mind, so that when you become solid engineers, you need to have the reasoning skills. Why am I doing this? It's not that you just need to go and mark up just because you're getting marked. No, you need to understand so that you're going to apply all your engineering things when you're using in your job. If you're really inside your core or something, you will surely use all your knowledge to put inside your system or skills. Whatever you are designing, you will put inside your skills what you've learned in your 4 years of engineering. Your 4 years of engineering is not a waste. Actually, you should not you now I understand that the job scope or the job opportunities is very less, but your knowledge is not something which can be satisfied by some other course. That is what I would like to emphasize here. So whatever you learn, you should make sure that even when it is hard to get a job, you should not think that all my 4 years is waste. No, the 4 years you studied is something as knowledge which can never be taken by someone else. It is always yours. So you need to come to that type of mind so that you can reason every single thing and then you know the answers what you require. Especially in this automation industry, when your reasoning skills is high, you get to learn a lot of things. And I think I've covered most of the things. Sorry for the psychological talk or whatever. I just need to share my experience with you so that you don't make the same mistake what my classmates did during when I was studying. So I think that's all. So I think we can go to the question and answer session. If you have any questions, you can shoot up.
Yeah, good evening, Ramnan. This is Rohan.
Yeah, Rohan, go ahead.
Can you is how COVID-19 is impacting robotics industry and like the workflow and practical approach for global development.
Sorry, come again. I don't understand your question. Sorry. Hello.
In your perspective, can you tell us how COVID-19 is impacting robotics industry?
Okay. Okay. Wonderful question. Okay. So COVID-19, I would say currently, as you know, in this COVID-19, a lot of places, there are companies which are shut down and we are working from home. Unlike other industries like IT or something, your automation, you need to work, even you work from home, your project management skill, I mean, you can work from home, but your missions which needs to be done, you need to go there. Fortunately and luckily in Malaysia here, I think they've already controlled the pandemic situations from the start. So I think now we've already started going to work like 2 months already. From April, we already started to go to work. So by doing that, we are able to continue our scope, but due to the traveling restriction, we are not able to meet our customers' requirement of shipping on date. But since they know that this is a global pandemic, so we cannot do much on shipping this thing. So I would say how it is affecting is that a lot of parts which we need to purchase from overseas or something like the standard parts you cannot get on time. So by that time it's something like you will lose track on your schedule, and it will also impact a bad impression on the customer when it is some other reason. But I think currently, since everyone is aware of the situation, it won't affect much on the reputation or impression from the customer. It's just that you will you will delay your future projects which you need to do on time. It's just that your timing or your scheduling will be impacted by the COVID-19. I would say this is the condition in Malaysia, but the overall global pandemic, I would say it will be a very big loss on this automation and robotics industry. From an article I read, it's something like over the world, it's more than we've lost 27 billion only in the automation industry, because we were not able to deliver all the deliverables on time, or we were not able to get the parts on time. And also the production, if I think actually Apple or the other companies which are leading now, they were actually planning of releasing a new phone by I think July. But now, since due to this pandemic, they cannot test their parts, so the product is actually moved to like 2 or 3 months ahead. So this is like affecting their scheduling, all those things. So I would say, as a short summary, that if the global pandemic is affecting us in some way, it is on scheduling only. Did I answer your question?
Yeah, thank you, sir.
Okay, thanks a lot.
Good evening.
Yeah.
Good evening. This is Gopalakrishnan.
Yes, go ahead.
I would like to ask one question. It's purely academic. So we
Okay.
want to become a good mechatronics engineer. What are all the skills that require? What are all the subjects they have to learn?
Okay. I would say wonderful question. Thank you for asking. Many students will learn this. The first thing, as a mechatronics engineer, before all this mechatronics, you need to become an engineer. Means you need to have the reasoning skills to make sure that you get the answers what you want. Secondly, coming into your question, mechatronics engineer, I would say currently all the subjects you study is going to help you in some way. If let's say you are good at designing, then it's going to help in your designing skills. If you're good at PLC programming subject, what you have, you can become a programmer as well. So all I would say the other line or other subject of engineering will not. They all have future. I don't say they don't have future. That it's just that they don't have much future in automation industry. It's just that when you're doing mechatronics, you are like completely learning about the automation industry, even from the depth until the end. Even some things which I don't know, you might already know. I would accept that. There is no disagreement in that. A lot of things that you know, I might not know, because you are learning the subject from mechatronics point of view. But still, if let's say you still require me to specify some subjects, I would say CAD. You will have you will have a lab in AutoCAD, and then it would be better if you know SolidWorks and PLC circuits, and then even the electrical circuits also you can use a lot. And currently, I would say in the market, the most hired automation people from Mechatronics Engineering is something as PLC programmers and the HMI engineers. HMI is something like a human machine interface for that. How do you say the machine to do what you want? You actually interact with the machine through the interface, which is known as the human machine interface. So these are the two main criteria on which a lot of mechatronics engineers are brought inside the automation field. Did I answer your question?
Yeah, thank you.
Okay, thank you. And one more thing I would like to say is, if you anything you want to ask, you can ask. Means இங்கிலீஷ்ல தான் கேட்கணும் இல்லை தமிழ்ல கேட்கலாம். I would தமிழ்ல எக்ஸ்பிளைன் பண்ணுறது எனக்கு இன்னும் ரொம்ப பெருமையான ஒரு விஷயம் கூட. ஸோ நீங்க தமிழ்ல கேட்டாலும் I don't care.
So participants, if you have any queries.
Sir, this is Rajshekhar, sir. I have one, sir. Will this COVID-19 pandemic will affect our placement, sir, in forthcoming days? This in the robotic field and automation field.
Final year, Abba?
No, sir. I'm in pre-final year.
Okay, good. I think it's really interesting that a pre-final year student asked me this question. Okay, I would say in the current situation, there might not be any affecting factor for the COVID-19 because currently we are behind of schedule for a lot of projects and a lot of future projects which are on hold because of this pandemic. So obviously to meet all the criteria and all the timeline, a lot of companies will come to hire more people instead of the actual type of people. So I'm sure that for placement point of view, this won't affect. This COVID-19 is not going to affect. It's just that you will have your interview or whatever a bit late, but it won't affect the number of intakes on the automation field. Did I answer your question?
Thank you. Yes, sir.
Okay, thank you. Thanks a lot. Thanks a lot for asking. And I think most of the people you no need to call me, sir. You can call me now because I just finished my course before 3 years. I'm not too old actually.
So if you have any queries, then unmute yourself and raise your valuable questions to our research person.
Seems no question. So I think everyone understands, is it? Then if you think that everyone understand, if you don't ask me questions, I will ask you questions.
Yeah, 1 second. I am Trivenkadam again.
Yes, sir. Yes.
Sir, I have one question. Like,
yes, please.
Any internship opportunities like virtual internship is possible in your side, like Malaysia, or any international exposure to get internship? It may be like due to this pandemic situation, can we have virtual internship possibilities like mechatronics side or automation side or robotics side, PLC, HMI, etc. So there is any possibility, sir? Can you recommend this kind of?
Okay, I would say that normally during this, let's say HMI or all the other subjects and the internships they ask, more or less on automation industry, it is very hard to get a virtual internship because you're not physically present here, but your system is physically present. So most of the companies will have a concern that due to this webcam, there's a lot of confidential things which may leak outside. So I think most of the companies will not come forward to give a virtual internship. But when it comes to after COVID-19 to apply for internships, I would also say the chances are very less here than in India because here there are already a lot of projects we need to meet in schedule, and probably the top management will think that of course there is a slot for internship for every year, and every 2 semesters means every 6 months there'll be some amount of internship intake. But due to this COVID-19, they will hire more engineers than the internship because they need to finish their. So I think this year, I would say placements will not be affected by the pandemic, but the internships might be affected because they need some experienced people to drive through the project to finish on time. But if let's say anything else comes in my side from my company, I will throw an email to you, sir. I will email to you. Yep.
Okay, thank you so much, sir.
Hello.
Yes.
Hello, sir. This is Ilangumaran.
Yes,
Professor
yes,
of
go ahead.
Mechatronics Engineering.
Yes.
First of all, I'd like to thank for your lecture, clear-cut explanation in all details. So
Okay.
I'd like to have, so in the conclusion slides, you have given determination of payload and axis for a robot.
Yeah.
It's very critical as well as while we are designing the automation equipment. So what are all the important parameters or criterion which is influencing the designing of equipment other than that of payload and axis for robot?
Okay, wonderful question. Okay, I would say that first of all, the different parameters which we need to consider is actually depending upon each customer's product. If let's say customer is or consignee is requiring you to build a machine to their product, then we will have separate kind of parameters which we need to meet for that separate product or for that specific product. So if let's say I'm just giving you an average normal scenario where customer is giving us a sensor to test in our machine. So the first parameter we need to consider is how are we going to hold the product, because without holding the product you will be unable to test the product. So you need to know how you will hold the product. So that is the first ever parameter you will get into your mind. So first you need to design a holder specifically for that product, and then sorry, okay. Okay, I think I've given control. Okay, so sorry, who's moving anything? Okay, all right. So I was like, okay, I was telling that first is the holding protocol of the product. The second thing, what we need to second parameter which we need to take in account is how are you going to pick the module? Or normally in automation side, we call the product as product or module or unit. So different ways depending upon the size of the product. So if let's say the product is small, then you need to consider how are you going to pick the module. Means how are you going to pick from the tray or your machine and do the testing, and how are you going to place it outside. So this is the second parameter which you need to consider. How are you going to pick and place the module? The third parameter which we need to go through is different type of testing criteria. If let's say customer require us to test some electrical tests, then you need to have a SMU, which is a source of single I'm sorry, I forget the SMU abbreviations. It's an unit where you give the current and then read current, or you give voltage and you read voltage. So this is SMU. Or if let's say you need to do electrical test, you need to give certain amount of hardware so that you support the products. Some of the sensors which we use in our phones or the customers equipment is something like, you need to know how does this module react when you define and design certain amount of hardware so that you can give the best of your testing to the module and you meet all the criteria given by customer. This is for electrical test. Then if customer requires us to do the imaging test, which is the module sometimes might be, one of our customers also doing an endoscopy camera. You can see a lot of medical applications where there's endoscopy, which, while to explain so that everyone knows, something like there will be a tube so that they will, for let's say you're suspecting of ulcer or whatever, they will try and then it will go through your stomach by as a camera, a very tiny piece of camera. So now there is in the advancement, I would say that there is a product which is coming which does not need the tube. It's just a capsule, like it's a very small, like what I said, is 1 into 1 mm. You just need to swallow and then it'll go and then it'll dispose the next day. But all the required images which you need to see through your food tract and your digestive system, everything is captured through the capsule, and then it is given out as in the form of Wi-Fi. Sorry. So normally you can connect it to your phone, and then you can pass the file to the doctor or whoever required. It is something like that. So if the module is something like you need to take imaging tests, then you need to design some test chart or a view for the module to capture and then give you the data or the required readings. This is the third parameter. So the first is how you hold, the second is how you pick and place, the third is what kind of test you're going to apply, and how is the test going to affect or communicate with the module. After that, the fourth parameter you're going to see is how are you going to make sure all the hardware in your system is identical and there is not any one place which is going to cause a variation. So this is the fourth type of parameter you need to consider. And I think the fifth and the last type is how are you going to meet the testing of UPH, which is the units per hour. You need to meet some target. So you need to design and consider that parameter so that you can make sure that your equipment can meet the required unit per hour target. So these are the very main and major type of parameters which we need to consider on building an automation machine, and the parameters might increase depending on the product as well. If the product is really sensitive or really it needs to have more amount of tests or whatever, then we need the parameters will increase accordingly. So I think I've given an explanation on how or what are the parameters which I need to consider to build a machine. I've answered your question. If you're not clear, you can let me know.
Thank you for the elaborate explanation.
All right, thank you. No problem. Anything else? I expect more interaction from students. Anything else using or whatever, you can just shoot the question. Because why I'm saying this is because the more and more knowledge you have, the more and more when facing an interview or wherever you're going into the world,